We are officially live. It is Friday night. Well, for me, almost Saturday morning here on the East Coast. So today, we are going to be talking about these things called critical points. As you join in, please feel free to hit that heart button. I will go ahead and start waving at people by pressing the button. But in case I can't wave to you by pressing that button, I'll wave to you now. Hi, everyone. So, yeah. Oh, I almost forgot. Well, actually, I'll mention that at the end. So, yeah. Welcome on in, everyone. Hopefully, everyone's doing good. I had a good Friday. Um, no football tonight, but that's okay. Um, ooh, I just completed a challenge. Awesome. I don't know what challenge I completed, but hey, I just completed one. Yay. Let's take a look and see. Oh, I think I went live for a minimum amount of time. Yep. Awesome. Cool. What's my next challenge that I have to complete? 500 comments, reach 2437 followers, collect 5,500 diamonds. Cool. Good to know. Thank you for the heartbeat, Fady. Thank you so much for that. Go here. Tonight, let's go ahead and look at our current schedule. So we did mean value theorem last night. So we will go ahead and check that off the list. Actually, let me get a better pen for that. Oh, here's all my pens. Let's use this pen. So I'm gonna go ahead and oh, maybe not. Maybe that wasn't such a good pen. That's okay. I have plenty. Maybe this pen. There we go. That pen works. So tonight, it says that we are going to be. Hold on a moment. I said we were working on critical points, but next on the list is extreme value theorem. So turns out, I was actually thinking about this today, and I'm actually going to be doing both extreme value theorem and critical points at the same time because they're both related. So in that way, I just decided, hey, I had to catch up a day anyway, so why not just do both of these at the same time and kill two birds with one stone, right? So yeah, so that's going to be the focus of tonight, and then tomorrow we're going to be back on schedule talking about concavity. So yeah, and we're almost done calculus 1. Last I took a look at the list, I think after Sunday I have maybe one or two more topics that we're going to go over in Calc 1. Optimization, I'm going to spend at least 2 lives on because I think it's one of the more difficult concepts. So it's something I think is worth devoting more than one live to. So that's why we're not going to be done like Tuesday. Because I really want to devote. Am I going to Calc 2 afterwards? Absolutely. So I'm going to be jumping. So as soon as I'm done with Calc 1, I'm going to go straight into Calc 2. That is the goal. All right, so I'm just going to do one more quick check of everyone. Make sure that I was able to wave at everyone who I was able to click the button for. Thank you, Blondo, for the follow. Oh, speaking of follows. Oh, I know nothing of calc, so this probably isn't for me. No problem. You know what, Izzy? We're happy to have you anyway, because it's good to open your mind to stuff you don't know. So it's good that you joined us tonight anyway. On a scale of 1 to 10, how's your algebra? I don't even know what a critical point is. Well, I'm probably in 6 in algebra. That's okay. Well, that's why you're here. So that way we can learn what critical points are. There are going to be some people in here who already know what they are, and that's okay. But there are also people in here like you that don't know what they are, and that's okay too. You're probably a 6 in algebra. Okay, so you do understand algebra, so there's going to be a lot of algebra. They say the hardest part of calculus isn't the they say the hardest part of calculus isn't the calculus. The hardest part of calculus is the algebra. Can you teach triple and quadruple derivatives? Sure. We might actually run into some of those here soon. Absolutely. Absolutely, Izzy. I definitely agree. And believe it or not, I almost bet you that you might already know some of this without even realizing that you do. But for those of you that are new, we're going to take these things called derivatives tonight. And what is a derivative? Well, the derivative tells the story of the slope. So it tells us how a function's slope behaves at a single point. So we'll see a lot of those tonight. And I have 3 note cards full of all the rules that we'll need. So as we do them, I'll show you those rules again. Or maybe this is the first time seeing those rules. If that's the case, then they'll be here for you. So, so let's go ahead and get started talking about critical points. So our first question we have to ask is, what is a critical point? What is a critical point? Well, to answer this, let's take a look at a graph. So I'm going to go ahead and attempt to draw this, but I apologize if my drawing is awful. So here's my graph. There we go. And let's say I have a function. Let's say I have something like this. Let's say I have something like that. So critical points are where the slope of a function is equal to 0. So there are 2 types of critical points that we can run into. We can run into this. I'm going to draw my tangent line. This would be called a maximum. Then I have another critical point here. And if this is a maximum, what do you think this would be called? That's right. That's exactly right, Izzy. That's exactly right, Jacob. That it is a minimum. Thank you, Ferg, for the follow. So we have maximums or minimums of functions. And that is what a critical point helps us to figure out. So, tonight, we're going to be finding a lot of maximums or minimums. Yes, that's exactly right. So, in order to find these, what I need to do is I need to take. So, if I'm given a function, the first derivative is going to tell us where the critical points are. So, we can find that once we find our first derivative, we set that equal to 0. But again, we'll see that more when we get into actual problems. But I just wanted to show us for a moment what exactly. Thank you, Gabby, for the follow. And thank you, El Bardo, for the follow. Would this be how they find the peak and valley of something like a radio wave? Yeah, I'm not sure. I would think so. Thank you, Jeremy, for the follow. Wow, thank you for the heart me, Izzy, and thank you for the 16 roses, Fady. So, let's go ahead and talk about how to find critical points. So, there are two rules that we need to have to so critical points exist. So critical points exist when one of two things happen. Either A, or actually one, f prime of x is equal to 0, or 2, f prime of x is undefined, but f of x is defined. So sometimes we're going to have points where we're going to have values where our critical point makes the derivative undefined, but it's originally part of a domain. For example, let's say our derivative causes division by 0. Well, as long as that point didn't cause division by 0 in the original function, then it is still a critical point. Oh, curve sketching, good times. Yeah, indeed. Thank you for the 11 more roses, Fady. It is a helix. That's right. So, let's go ahead and look at our first example of the evening. So, let's say, example number 1. Let's find the critical points of the following function. Find the critical points. Oh, I've never seen that one before. Thank you, El Bardo, for the rock star. I have never seen that TikTok GIF before. So thank you. So find the critical points of the following. So f of x is equal to 1/3 x cubed minus 9x plus 24. Thank you, SF Dope, for the follow. And thank you, Karashon, for sharing the live. So here's what we need to do. So first, I need to find any points that cause this function to be undefined. Well, remember, in order for a function to be undefined, when we talk about calculus, we need either negative inside a square root or division by 0. So here I have an x cubed and an x at a first. So I'm not going to run into any negatives inside the square root. So I is not going to be a thing. Thank you, Ferg, for sharing the live. And also, because I don't have any x's in a denominator, there's no chance of division by 0. So we know that this function does not have any, is defined everywhere. So here are the steps to finding the critical points. First, we checked for This is so difficult. Don't give up, Ashley. We've only just begun. Thank you, Alberto, for the heart me. So we have. So we've checked for. Thank you, the Celestial Code X, for the follow. What topic is this? This is critical points. What time are these lives usually? That is actually a really good question. And actually, I was going to mention that in a little while, but I am going to I'm going to say it now. So I've been looking at my live times, and I realized first I need to have a second live. So I've been saying all week that I was going to tell you all tonight when that second live was going to be. So I decided to move my live schedule a little bit. So first, I'm going to go live every day. So my first live is going to be. So let me quickly write this down because I forgot to write it down. This is going to start on this is going to start on October 6th. So here is my brand new live schedule. So this is going to start on Monday, October 6th. So I'm going to have my first live at 2 p.m. Eastern Standard Time. And then the second live is going to happen at 10 p.m. Eastern Time. So this live here is going to focus on everything from algebra to pre-calc, and this live is going to focus on everything from calculus on up. Thank you, Luke, for the follow. Thank you, Alberto, for the 98 roses. Thank you, Jacob, for the follow. Trig, yep, so that's going to fall onto this live. And don't worry, because if you miss a live, you can always find it on here. So here is where I post all of my lives. Do I teach trig? I do indeed. Thank you, Astrobird, for the follow. How long are your lives? I'm basically refreshing from calculus all the way to linear and differential equations. So I usually try to go live about an hour and a half to 2 hours at a time. Calc 3? Yes, I do. Calc 3, I'm going to get in. I do tutor Calc 3. So Calc 3, when it comes to these lives, I'm going to get into Calc 3 sometime, if I had to guess, probably sometime around December. And again, that's just a guess. I'm not sure if that's the case. But I have to take a look at that schedule again. I'm having a hard time learning how to graph functions. I'm sorry to hear that. If you have a question, feel free to DM me and I'll be happy to answer that for you, Cassandra. Thank you for the 5 Bat Boy Taters, SF Dope. AP Calc is high school, right? Correct. That is correct, Pink. You're welcome, Cassandra. You are most certainly welcome. Anyway, back to this. So, we've checked for for the domain, and we found that it's defined everywhere for all reals. So now my second step is to take the derivative. So I'm going to find f prime of x. Now, for those of you who are just joining us for the first time, here is how we take the derivative of this particular function. So, I'm going to put my derivative rules up here. So, let's start with this first one. I have 1/3 times x cubed. So what I'm going to do is I'm going to follow this first rule of derivatives. And what does this rule say? Well, it says that if I have a variable raised to a power, to find the derivative, I take the power, move it out in front of the x, and multiply by whatever number's already in front of the x. Then I subtract 1 from the exponent. So here I have 1/3 times x cubed. So here, I'm going to take my 3, move it out front, and I'm going to multiply it by this 1/3. So I have 1/3 times 3. Well, 1/3 times 3, we say bye to the 3's. So I have 1 times x to the 3 minus 1. 3 minus 1 is 2. So it would be x squared. And the reason why I'm not writing the 1 here is because when I have a variable without a coefficient, it's assumed that the coefficient is 1. What grade of math is this? So calculus I've seen high schoolers take calculus, but it's also college level math. So it really depends. Right. Yes. That is right, someone. Thank you, Ash, for the follow. So now I have minus 9x. So remember that a variable without an exponent is the same as that variable raised to the first power. So again, I'm going to take my exponent, move it out front, and multiply it by this negative 9. Negative 9 times 1 gives me negative 9 times x to the 1 minus 1. Thank you, Lily, for the follow. So x to the 1 minus 1 is 1. And remember that x to the 0 is equal to 1. So this is the same as negative 9 times 1, which is just negative 9. And then I have this plus 24. So there's no variable next to that 24. So this is what we call a constant. And if we look at rule 4, if f is equal to a constant, then its derivative is equal to 0. So the derivative of 24 is 0. Difference of squares can be used here, correct? Absolutely. And I was just about to get there. But yeah, you're absolutely right. You're absolutely right. So now from here, now that we found the derivative, in order to find the critical points, we need one of these two to be true. Either f prime of x has to equal 0, or f prime of x has to be undefined. Well, x squared minus 9 is not going to be undefined, but I have 0, and so f prime of x is going to equal 0. So what I'm going to do is I'm going to set my derivative equal to 0. So I have 0 equals x squared minus 9. And now the calculus is done. All we need to do now is find what x equals. So if 0 is equal to x squared minus 9, well, here I can rewrite x squared minus 9 as 0 equals x squared minus 3 squared. And here, I can use this thing called difference of squares. So difference of squares says that if I have x squared minus a squared, then it's going to equal x. It's going to be able to factor as x the quantity x plus a times the quantity x minus a. So here, my x is x and my a is 3. So this is going to be 0 is equal to the quantity x plus 3 times the quantity x minus 3. And now I can use this thing called zero product property, which means that either one of these has to equal 0 in order for it to be 0. So either x plus 3 equals 0 or x minus 3 is 0. If x plus 3 is 0, then I can figure out x by subtracting 3 from both sides. So I have x equals negative 3. Or if x minus 3 is equal to 0, then I can add 3 to both sides, and I have x equals 3. So these two are what we call my critical points. I'm glad you love math. Math is fun. Although, let's watch the language, please. Why wouldn't you factor by FOIL instead of difference of squares? What do you mean? I think if you recognize a difference of squares pattern, it's easier in FOIL. Absolutely. I mean, I could factor this by saying, okay, what two numbers add to negative 9 and, no, what two numbers multiply to negative 9 and add to 0? But rather than do that, I could recognize that this is difference of squares. So I can just plug in the difference of squares formula here. But there may be times where we do have to factor that way. So now, here's the question. We found the critical points. Now, which one is the maximum and which one is the minimum? And to do that, what I'm going to do is I'm going to use a number line. I'm going to insert negative 3 here. I'm going to put 3 here. And I'm going to test different values that are in these ranges to tell me which one is the max and min. So a maximum is going to be a plus followed by a minus, and a minimum is going to be a minus followed by a plus. Let me show you what I mean. So let's go ahead and pick a value less than negative 3. What would be a value less than negative 3? Negative 4? Okay, we can use negative 4. So what I'm going to do is I'm going to plug in negative 4 into the derivative and see what the value is. I don't care about the actual value. I just care about whether it's positive or negative. So I'm going to go ahead and plug in negative 4 here. So I have negative 4 all squared minus 9. Negative 4 all squared is 4 squared is 16, and negative 1 all squared is positive 1. 1 times 16 is 16. And 16. Now my pen's not going to work. That's okay. I can switch pens. Or maybe not that pen. I think it's time for this pen to hit the road. Let me go ahead and bring out a few more pens. I'll pick this one. So I have... Would it just be the paper? Huh. This is, if you needed proof that this is live, here it is. Because if this weren't live, why would you see pens malfunctioning? Yep, here we go. So here, I know, right? It is crazy. So negative 4 all squared is 16. And 16 minus 9 is 7. Now, I don't care about the value. What I care is whether this is positive or negative. So, is positive 7 positive or negative? What do you think? Is positive 7 negative or positive? And trust me, it's not a trick question. Bifo says positive. Bifo says I'm positive. K4 says positive. Alexander says positive. Yeah, so it is positive. So I'm going to put a plus sign here. Luke says positive as well. Awesome. Now, let's pick a value between -3 and 3. May I suggest 0? So Lara agrees. Let's go with 0. So, I have... So now I'm going to plug in 0 into my derivative. So I have 0 squared minus 9. 0 squared is 0. 0 minus 9 is -9. And -9, last time I checked, -9 is negative. So that's going to be negative. Just slow down. Okay. So now, what I'm going to do... Guys, if you can't factor easily, I suggest just practicing your algebra AI. Okay. So, we know that between -3 and 3, the slope is going to be negative. A lot of students struggle once they get to critical points in second derivative tests. Agreed. This is actually one of the... This, related rates, and optimization are some of the more difficult things in Calculus 1. It would be a max point, that's right. So because I go from a positive slope to a negative slope, that means that -3, x equals -3, is a maximum. I'm just going to abbreviate it as max. So now, let's pick a value greater than 3. What value would you like to choose? Six? Okay, let's plug in 6. So I have 6 squared minus 9. Well, 6 squared is 36. 36 minus 9 is going to be what, 27? And 27, positive 27 is positive. So I'm going to put a plus sign over here. And since now my slope goes from negative to positive, I can conclude that x equals 3 is a minimum. And that's it. So here, I know that negative, if I were to draw this out, I would have from negative infinity to -3, my slope is going to be positive. So that's what this plus sign is symbolizing: positive slope, then negative slope. How would a sketch of this function look like? Okay, let me get my graph paper. Let me get the graph paper. Nope, that's my lined paper. Hey, Brandy, how's it going? Welcome on in. So I'm going to approximate what this graph will look like. It's not going to be perfect. And for those of you who are familiar, I can't draw. So I apologize for how awful this graph is going to look like here in a moment. I'll just use this for now. Can you help me with Lagrange multipliers? So tonight I'm going to focus on critical points, but if you have a particular question, Max, feel free to send it, DM me, and I will help you with it. So here's my graph. So I'm going to label my critical points. So 1, 2, 3, and 1, 2, 3. So here's my max. Oh, this should be -3. Here's my max, and here's my min. So so we know that um actually, what would the zeros be here? So here's an approximation of what it looks like. And again, I'm going to ignore where the zeros are for now. But we know from negative infinity to negative 3, our slope's going to be positive. So it's going to do something like this. And then at x equals negative 3, my slope is going to be 0. And then from negative 3 to 3, my slope is negative. And again, at 3, it's going to be 0. And then it goes straight up from 3 to infinity. Again, this isn't exactly what the graph's going to look like, but it's an I'm choosing for the second to ignore where my zeros are. Thank you, Muhammad, for the follow. Learning optimization right now and it is not cute. Okay. We're going to actually be going over optimization, I think, next week. So, yeah. Any questions on this problem? I'll go ahead and zoom out a wee bit. Thank you, Luke, for the follow. You love math? I do too. Math is awesome. Thank you for the follow, Beefo. Last time I checked, I was on. Thank you, Jenny, for the follow. Or Jenny. And thank you for the 2 more Bat Boy Taters, SF Dope. So, what was I going to say? Oh, so tonight I entered being 143 followers away from 2,000. I think I can hit that by the end of September. I'm sorry to hear that, Alex. Really sorry to hear that. So, any questions about this particular problem? All right. Let's go ahead and try another one of these. So, I'm going to move up to question number 2. So, let me actually move this a little bit. It's gonna move the camera a little bit, but I apologize in advance. I just need a little more space. There we go. So, next example. So let's say f of x is equal to 4x cubed minus 9x squared minus 12x plus 3. I started the semester taking calculus, but I dropped it. I'm sorry to hear that. Is it one of those classes that you had to take, or was it just to fulfill the math credit? And I mean, either way is cool. I don't know, Ringo. You tell me. You tell me. Yes, I'll try again next semester. Okay. And so for those of you who are interested, I do also offer online math tutoring. So if you're looking for that, please feel free to DM me and we can set up a consultation. And yes, the consultation's free. So yeah. So let's find the critical points of that function. So first, I need to check if there's any places where this function doesn't exist. Well, I don't see any square roots, so that would eliminate I. And I also don't see any chance for division by 0. So we don't have to worry about that. So, since now I know the domain of this is all real numbers, I am free to take its derivative. So, let's find the derivative of this function. So I'm going to zoom in a little bit so that way we can see the exponents a little better. Can everyone see that okay? Much better. Awesome, Latte. Awesome. Alright, so let's go ahead and find the derivative of this function. So we're going to use our power rule, which is rule 1. So quadratic, I haven't done math since high school, I have no clue. So our original function is actually called a cubic. And it's a cubic because the highest exponent is 3. Good question though, Lucas. Its derivative is going to be a quadratic. Thank you, Danny, for sharing the live. So here, first, I want to find the derivative of 4x cubed. So remember, I'm going to take my exponent, move it out front, and subtract 1 from the exponent. So if I have 4x cubed, what is its derivative? Is this considered a polynomial? Yes, it is. Hey, Tyrone, how's it going? Tyrone says 12x squared. Mike says 12x squared. Mr. Clean says 12x squared minus 18x minus 12. Yeah, that's exactly right, Mr. Clean. So yeah, so 4 times 3 is 12. And then x to 3 minus 1. 3 minus 1 is 2. So that goes there. Next, I have 2 times a negative 9 is negative 18. And then I have x to 2 minus 1, which is 1. And remember, variable without exponent is assumed to be x to the first. Can I learn Calc 1 in 4 weeks? You could. I don't recommend it. Math is not something worth rushing. Is related rates easy because I'm learning that next week? So, a lot of related. How well do you do at breaking down word problems? Pretty good. Okay, so a lot of people really struggle with when it comes to related rates is breaking down the word problems and knowing which formulas to actually use. Thank you, beloved ruler, for the follow. So if you're good at breaking down word problems and you know most of your geometric formulas, then then I would say it's going to be easier. Thank you, Mr. Clean, for the follow. And then remember, x without an exponent is the same as x to the first. So I have 1 times negative 12 is negative 12. And then I have x to the 1 minus 1, which is 0. Thank you, Mr. Black, for the follow. So remember, x to the 0 is the same as 1, so this is negative 12 times 1. And then I have plus 3. So 3 is a constant, and so the derivative of a constant is equal to 0. So instead of writing plus 0, I'm just going to not write that. How much will I use a pre-calc when I finally start calculus? So a lot of calculus comes down to how well do you understand algebra and how well do you understand trig. Um, and thank you, Ophelia, for the follow. Can you explain existence and uniqueness of solutions for initial value problems? So tonight I'm gonna be talking about critical points. We're gonna be in differential equations probably. So we are gonna go over some in calc when we go over calc 2. I don't know exactly when. This week I learned about why prime and logarithmic differentiation it wasn't that difficult. Yeah, I don't think it is. Do you think it's late to change careers at 50 to engineering? I'm not sure. Um, that's cheating. What's cheating? When will I start at Calc 1 again? So actually, I have all my lives recorded since August, and you can actually find them here. You can find them here. But at some point I may restart Calc 1 as well. Just because some of the videos I think I could do a little better. Can you do Calc 3? So Calc 3, I'm probably not going to get into that until maybe December at the earliest. I'm a semi-retired physician. I'm going back to school to get a master's in physics and teach. That's awesome. That's really cool, Shamrock. That's really awesome. Thank you, Space Coyote, for that. Yes, I was just about to get to that. So, here, now, I need to check to see if this can be undefined anywhere. Well, again, I don't see any square roots and I don't see any division by 0, so I'm not going to have to worry about that. So now, I'm going to set the derivative equal to 0. So 0 is equal to 12x squared minus 18x minus 12. Does anyone see what I see? Thank you, Lucas, for the follow, and thank you, Xenogs, for sharing the live. But yeah, does anyone else see what I see? About this polynomial? What do we think? All right, 85 people on here. Let's go. Yes, Zora, that's exactly right. I can factor out a 6 out of all three of these terms. So, I can factor out a 6, and I'd be left with what? 12 divided by 6 is 2, and x squared goes along for the ride. Negative 18 divided by 6 is negative 3. X goes along for the ride. And negative 12 divided by 6 is just negative 2. Thank you, Amy Davis, for the follow. Amy Reinhardt Davis, excuse me. Sorry about that. So yeah, now I'm going to go ahead and divide everything by 6. That way I can say bye to this 6. So I have 0 is equal to 2x squared minus 3x minus 2. Yes, bye 6. So yeah, so now from here, how can I factor that? Or would it make sense to just do quadratic formula here? I could factor. So here, how did I remove the 6 again? Sure. So all three terms here, their greatest common factor was 6, right? Because 6 goes into 12, 6 goes into 18, and 6 goes into 12. So here, I could factor out 6, and then I divided by all three of these terms by 6. That gave me this right here. So because of a 0 yeah, exactly. So from here, the reason why I said bye to 6 was because 6 will never equal 0. So rather than keep it there, we can just divide, because I'm multiplying 6 by all of that. And so I'm undoing that multiplication by division. So that's how a 6 went bye. Yeah, no problem. No problem at all. Can you take the integral after to put it back? So here I'm not. Why not divide by 6 directly? I'm not quite sure what you mean. Oh, let's go. 100 plus people in the live. Hello, everyone. Is this derivatives? It is indeed. We're actually going over critical points tonight. Hey, Darko, how's it going? Welcome on in. So now, I'm going to go ahead. Thank you, Benjamin, for the follow. So now, let's go ahead and factor this. So I'm looking for... You lose your constant if you integrate. Right, so if I were to take the integral, I'd have to add a plus c too. Why do you keep skipping my comments? Use the quadratic. I'm not trying to skip your comment. They're going fast, so I'm not always able to read them. So I do apologize. And yeah, I could use quadratic here, and it's going to give me the same answer. I'm just going to choose the factor. So let's go ahead and factor this. So I have two numbers, multiply to negative 2, and add to negative 3. So I'm going to bring my x here. Multiply to negative 4, add to negative 3. Will you do derivatives anytime? I'm doing them right now. Yeah, exactly. Like I said, we could use the quadratic formula too, and we could definitely find it that way too. So here, I have negative 1 and negative 4, or 1 and negative 4, and 2 and negative 2. So my factors are going to be negative 4 and 1. So now, from here, what I'm going to do is I'm going to go ahead and divide both of these by 2. So this is going to be 0 equals negative 4 divided by 2 gives me 2, or negative 2 rather, and 1 divided by 2. So this is going to tell me that the 2x is going to belong with the 1. So I think it's going to be x minus 2. Yeah. Times 2x plus 1. Why am I dividing them by 2? Because 2 is my a term here. Let's see if I'm right. So I have x times 2x is 2x squared. X plus 1, x times 1 is 1x. 2x times negative 2 gives me negative 4x. X minus 4x is negative 3x. And negative 2 times 1 gives me negative 2. Perfect. So yeah, I did do it right. Thank you, Crazy, for the follow. No, I prefer to write my steps out. Why didn't I do 2x on the other x? Here's why. Because I need... So, in order for this... If I had a 2x here and a 2x here, then this would be 2x. Then when I FOIL it out, I would have 2x times 2x is 4x squared, but I only have 2x squared. Yeah, no problem. So now, I know by the zero product property, either 0 equals x minus 2, or 2x plus 1 equals 0. If x minus 2 is equal to 0, then what must x be? If that's true, El Mexicano says 2, Space Coyote says 2, Lime says 2, God's USSOP1 says positive 2, Lucas says 2. Yeah, that's exactly right. X equals 2. And then, if 2x plus 1 is 0, then what must x equal? Thank you for the paper crane, Tim. El Mexicano says negative 1/2. Lucas says 1/2. Karma says negative 1/2. You're most certainly welcome, Jose. And I'm happy to bring this into the TikTok space. So it looks like we're having a disagreement whether this is positive or negative 1/2. So here, I'm going to subtract 1 from both sides. And I get 2x is equal to negative 1 equals negative 1, not 0.1. Dividing by 2, I get x equals negative 1/2. So these, thank you cat lovers for sharing the live. So these are my critical points. Now, let's figure out which one is the maximum and which one is the minimum. I'm going to bring out my number line again. Is this Calc 1? Yes, it is. Thank you. Thank you, me, for the follow. Yeah, but we're almost done. We're almost done, JS. Yeah, have a good night, Shamrock. Thank you for joining us. So negative 1/2 and 2. Yeah, we're pretty much done. If we were just asking for the critical points, then we would be done now. But just for fun, I want to show you which one is the maximum and which one's the minimum. How to find which one's the maximum and which one's the minimum. Thank you for the perfume share. And thank you for sharing the live, Lucas. And thank you for the follow, El Mexicano. So now, let's go ahead and find where our max and mins are. So here, in order to find these, I'm going to take a number less than negative 1/2 and plug it into the first derivative. Second derivative, correct? So the second derivative is going to give us something that's called concavity. So it's going to so second derivative helps us find which way the function is facing. Exactly, Brandsy. That's exactly what we're doing. We're doing the first derivative test. This is going to help us establish our max and mins. So, go ahead and pick a number less than negative 1/2. What number shall we choose? I saw negative 1 first, so we'll use negative 1. So here, I have, and remember, I don't actually care about what the value is, I just care about its sign. Thank you, Packaged Food, for the follow. So I have 12 times negative 1 all squared minus 18 times negative 1 minus 12. So negative 1 squared is 1. 12 times 1 is 12. Minus 18, negative 18 times negative 1 gives me positive 18. Minus 12. 12 minus 12 is 0. So that's going to equal 18. Thank you, Sour Apple, for sharing the live, and thank you for the follow. So, positive 18, is that positive or negative? That's right, me. That's right, Space Coyote. It's going to be positive. So, thank you, Kim, for sharing the live. So I'm going to put a plus sign right here. Thank you, Brand Z. That's right. Now, let's pick a number between negative 1/2 and 2. May I suggest 0? Thank you, Emil. Thank you, Space Coyote. Yeah, let's go 0. So I have 12 times 0 squared minus 18 times 0 minus 12. 0 squared is 0. 12 times 0 is 0. Negative 18 times 0 is 0. So I have 0 minus 12, which gives me, that's right, Bradley, negative 12. And so negative 12 is a negative number. Thank you. Thank you, money-making Manny, for the heart me. So yeah, that's negative, so I'm going to put a negative here. That's right. And now, let's pick a number greater than 2. What do you suggest? Alright, Brand, let's do 3. I saw 3 first, so let's do 3. So I have 12 times 3 squared minus 18 times 3 minus 12. 3 squared is 9. 9 times 12 is 108. 18 times 18, negative 18 times 3, that's going to give me what? 4, carry the 2 is 5. 54 minus 12. 108 minus 54 is going to be 54. 54 minus 12 gives me positive 42. So here, positive 42 is positive. So that is positive. Thank you, Lilma, for the follow. OMG, I been Googling, yo, check my math homework so much that even TikTok is showing me algebra. Hey, welcome on in. Ice chai and honey. And thank you, Hi, for the follow. So here's how we tell whether we have a maximum or a minimum. So maximums occur when my signs go from positive to negative, and minimums occur when the sign goes from negative to positive. So my maximum here, that's right, Brand. That's exactly right. So 1/2 is going to be my max or min. Is negative 1/2 the maximum or the minimum? Lucas says max. Jaden says, "Oh, is this calculus?" It is indeed, Jaden. This is calculus indeed. So yeah, thank you, Max. The answer is yes, this is a... That's right, Jaden. It is a max. Which means is... What would 2 be? Because I go from negative to positive, 2 is a... Jaden says minimum. That's right. This would be a minimum. That's exactly right, Space Coyote, and that's exactly right, Brand Z. So yeah, and that's how you find the maximum or a minimum of a function. Kind of cool, isn't it? What questions do we have about this? And I know I'm asking a lot of what questions do you have about this, but I want to make sure that we got it before we move into something a little more complicated. Any questions at all? Concave up? Well, in order to do that, we'd have... Thank you, Cher, for the follow. When my professor taught me this, I was confused. I'm sorry to hear that. Thank you, Godsend Bless, for the follow. And thank you, Sonia, for the follow. Derivatives can get complicated for me. They do for everyone. Can you relate this concept to something practical? I think I know the question you're asking, but go ahead and ask it. Thank you, Mia, for sharing the live. Thank you, Bado, for the follow. How do I do this? Please help. Okay. Where did I lose you, Jay? Thank you, Ice Chai and Honey, for the follow. There are several uses for this. There's applications in engineering. There's applications in medicine. Thank you, Samaj76, for the follow. There are a ton of applications for this. Just because we don't use this type of math on a daily basis doesn't automatically mean that there's no use to it. That would be like saying, okay, I don't work construction, so what's the use in construction? And I know that sounds absurd, but it's kind of the same thing as saying, where do we use it? Where is this math practical? It is. It's practical everywhere. And so, where did I lose you, Jay? What's hard for me is trying to simplify and get the function to a point where we find the derivative. Yeah, and that's the thing about derivatives. Oh, sometimes you don't even have to simplify. Sometimes you can just take the derivative of the function as is. Can you give me an example, Vojane, of what you mean? What's the X method? Never seen this. So this is actually a method that one of my friends showed me not too long ago. What you do is this is A times C, which you put up here, and then B goes down here. From there, you look at what two values here and here that multiply to this number and add to that number. Thank you, Space Coyote, for that. I definitely try to do a good job and show you this in a way that everyone can understand. Thank you for the follow. Unfortunately, I can't speak that language, so I don't quite know how to say your name. But thank you for the follow anyway. Absolutely. Thank you, Middleburg Shop Girl, for sharing the live. For example, x at a negative 1/2 can just be 1 over square root of x. That's challenging for me. Yeah, definitely. I can definitely understand that, Jaden. And a lot of it is, are you just doing calc in general? So tonight, we're focusing on critical points. I wish I was showed that years ago. I have to do a ton of factoring and then FOIL back to check work. Yeah, I didn't even know about this till a friend of mine showed it to me like 6 months ago. Actually, less than 6 months ago. So what I used to do was use this thing called factoring by grouping. So I would essentially do the same thing as this, but instead of just going from here to here, I would break this up into minus 4x plus x. If you're solving with x, can we do some wavelength equations? So tonight, I'm actually focusing on critical points and how to find the max and mins of a function. Will this topic be in Calc 3 or just Calc 1? I'm trying to think if this appears in Calculus 3. I don't remember. Okay. I'm doing Calc 1 right now and not really struggling with the Calc part, and yeah, that's absolutely they say the hardest part of calculus isn't the calculus. The hardest part of calculus is the algebra. So that's why I tell people all the time, make sure you have a solid foundation in algebra and trig, because both of us do show up a lot in Calculus 1. I have a question. Okay, Carlos, shoot. Do another? Absolutely. Let's go ahead and do another one. Let's 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 go ahead and amp up the difficulty a little bit. What topic am I going over? So tonight, I'm going over critical points. So let's go ahead and turn the page. Calc 3 maybe in Taylor series. I can't remember either. I honestly don't remember if this is in Calc 1 or not. I mean, Calc 3 or not. It's definitely in Calc 1. But I'm not sure about Calc 3. Alright, so let's go ahead and try 1. Let's ramp up the difficulty, though, a wee bit. So let's say I want to find the critical point of the following function. F of x is equal to the cube root of x minus 2. L'Hopital's law? No. So L'Hopital's rule involves limits. I actually did a live on that, I want to say, earlier this week. Let me take a look at my list, see if we actually did it this week or not. I know I've done it relatively recently. Yeah, so we actually did L'Hopital's on Tuesday. So, and if you want to find that one, find that live, you can find it here. You can find it here on this channel. But yeah, so let's go ahead and find the critical points of that function. You missed out. Joking. He's got it. Yeah, I have it. I have it right here. So if you subscribe to this channel, this is where all of my lives end up going. If you want to take a quick screenshot of that, by all means, go for it. Three, two, one. Okay. So first thing you do is find the first derivative. First thing to do is to check if this function is going to be undefined anywhere. So here, I have a cube root, but not a square root. So even if there's a negative inside here, it's still going to be in the real numbers. So, and I don't have division by 0, so I don't have to worry about that. So, and then Brandsy, yes, I'm going to take the derivative. So remember that this can be written as x minus 2 all to the 1/3 power. That's right, Brandsy. We're going to do chain rule. So remember what chain rule is. Chain rule says that if I have a function trapped inside another function, where is my... Oops. Sorry. I had a note card here a second ago. Yeah, I know. Sometimes I have the camera on one of my calculus books, so I just accidentally tipped it over for a second. Oh, here it is. So here, if I have a function trapped inside another function, what I can do is I take the derivative of the outer function, leaving the inside alone, and then I multiply this by the derivative of the inner function. So what I like to do on these lives is, and for those of you who are here on a regular basis, you know where I'm about to go. So instead of taking the derivative of x minus 2 all to the 1/3, let's instead take the derivative of bottle cap to the 1/3. What would be the derivative of bottle cap to the 1/3? Hey, Mary, how's it going? Yes, the bottle cap is back. Where's the orange one? I don't know. I actually don't know where that one is. You can't do the derivatives without your orange bottle cap? Okay, pretend that's orange. Let's use our imagination and pretend that's orange. So what is the derivative of bottle cap to the 1/3? That's right. That's what I'm gonna do for the one. I see a couple of people saying 1/3 minus 1. Yeah, that's what I'm gonna end up doing for the exponent. It's 1/3 times bottle cap to the negative. Yeah, that's exactly right. So I have 1/3 times whatever's underneath the bottle cap to the negative 2/3. What's underneath the bottle cap? The bottle cap is x minus 2. And then I take the derivative of what was underneath the bottle cap. So what was underneath the bottle cap was x minus 2. So I'm going to take the derivative of x minus 2. And for that, I'm going to use power rule. So remember, a variable without an exponent is the same as the variable raised to the first power. So the derivative of x to the first, that's right, it's going to be 1. Right? Because 1 times 1 is 1. X to the 1 minus 1 is x to the 0. And remember, x to the 0 is 1. So this would be times 1. And then the derivative of negative 2, well, remember, negative 2 is a constant, so its derivative is equal to 0. So yeah, this is our derivative. Now, I'm going to go ahead and simplify that. So how do I simplify it? Well, I want that to be I want this exponent to be positive. So I have f prime of x is going to equal 1 over 3 times x minus 2 raised to the 2/3 power. So now, let me ask you a question. Is there a point x, is there a number x that causes division by 0? That's right, Mary, it's going to be 2. Why? 2 minus 2 is 0. 0 to the 2/3 is 0. And 3 times 0 is 0. So this would be 1 over 0. So we'll say x equals 2 is one of our critical points. Because remember, the derivative is in critical points exist where this equals 0 or where the derivative is undefined, but this is defined. Hey, what kind of math are we doing right now? This is calculus. Critical point? Yep, that is what we are doing tonight. Thank you, C. Thank you, Sequay Rochelle, for the follow. And thank you, Martin, for sharing the live. I thought critical points were only when the derivative was 0. So critical points exist when one of two conditions is met. Either when that's 0, when the first derivative is 0, as you stated, but they can also exist where the derivative is undefined, but the function is defined. Something funky, though, is going to happen around x equals 2. Yeah, let's find out. So now what I'm going to do is I'm going to set the derivative equal to 0. So I have 0 is equal to 1 over 3 times x minus 2, all to the 2/3 power. So what should I do first? You're right. Why can't it equal 0? That's absolutely right, Mary. Why can't that equal 0? Is this calculus? It is indeed. Thank you, Lily, for the follow. Because 1 over any finite number will never be 0. Right. So the only way this will ever be 0 is if x is equal to infinity. And we can't really say x equals infinity is a critical point. So we only have one critical point, and that would be x equals 2. What's next after this topic? So what we are doing after this, and this is going to be tomorrow, is we're going to continue on this idea, but we're going to go into the second. We're going to find what's called concavity, which is just the second derivative. I'm in calculus, but my class hasn't gotten this far. That's okay. Isn't there branches of math where infinity is a valid point? Theoretically, I've never run into those, but yeah. Let's do implicit derivatives. Actually, I've already done that, NFL. I've already done that live, and you can find it. I just had it here a moment ago. I really need to clean this desk tomorrow. So, oh, here it is. You can find it right here. Thank you, NFL Glass Tips, for the follow. So you can find all my past lives here and on this platform. And thank you, Adam and Reese, for the follow. I'll give you a quick moment to hit that. It's called a stereographic projection, the thing I was talking about, by the way. Do you have a playlist that goes over topics? Yeah. So I have all my past lives on a playlist over there. I need to join these workshops more because my lectures be moving at light speed. Fair enough. Yeah. Cool stuff. It's related to a lot of the account I'm taking. I'm going to head out. No problem. Have a good night, Tsunami. Thank you for joining us. So now, let's figure out whether 2 is a max or min. Or maybe neither. Who knows? So this one's going to be a shorter one. Let's pick a value less than 2. May I recommend 0? Did you separate the problems? Which one? This one? And this one? Is that what you're talking about, Poppy? The quadratic and the x minus 2. I'm squaring the demons. Okay. Saving me right now. Have a quiz this coming Monday on these. Will you be going? Yes, I will. And those are actually tomorrow. Hey, Math Tutor. How's it going? Oh, I'm squaring the denominator. Yes. Yes, of course. That was kind of weird for a second. I'm like, what does that mean? Is this only Calc 1 or can you tutor Calc 2? Yeah, I tutor Calc 2 as well. And actually, we're going to be moving into Calc 2 probably in the next 2 weeks. Bet I'll try to make it live tomorrow. Awesome. Well, remember, even if you... It would be great if you do. But if not, remember that all my lives are going to end up here. Thank you, Jose, for the follow. Can you go over the square root of x with the derivative as h approaches 0? I get confused on square roots. So I'm actually just focusing on critical points tonight. But if you want, I've already done a live on limit definition of a derivative. But if you want, feel free to send me a particular problem. Feel free to DM me, Poppy, and I'll be happy to go over it for you. When do you get to integrals, and are you going to do Riemann sums? So integration is going to be in about... So Riemann sums are going to be one of the first things I do in Calc 2. That's probably going to be in like 2 weeks. Have you previously done and posted Calc 3 videos? Nope. Thank you, Hi, for the follow. And thank you, Leo Fit, for the follow. Any problem, to be honest, you're awesome. Thank you, Poppy. I'm happy to hear that. Yeah, just feel like that. Just feel free to DM me any problem, and I will go ahead and work on that for you. Thank you, Middleburg Shop Girl, for sharing the live. Nice, can't wait for integrals, as can I. Thank you, Lauren, for the follow. Anyway, let's find the max. Let's find whether 2 is a max or min. Thank you, Bones, for sharing the live. Alright, so let's pick a number less than 2. I like that idea high. I like 0. So let's plug in 0. So I have 1 over 3 times 0 minus 2, all to the 2/3 power. So, remember, I don't actually care about its value. All I care about is the sign. So I have 0 minus 2 is negative 2. So that's 1 over 3 times negative 2 to the 2/3 power. So this is, so remember that x to the m over n power is equal to the nth root of x to the m. So if I have negative 2 all to the 2/3 power, it's the same as the cube root of negative 2 all squared. Negative 2 all squared is 4, so this would be equal to 1 over 3 times the cube root of 4. Now, so this looks like it's positive. So why? Because positive 1 divided by positive 3 times cube root of 4. So that's going to be positive. So we know that we have positive there. Now, thank you, Uppercase, for sharing the live. And thank you, user, for sharing the live. Now, let's pick a number greater than 2. What do you say? What number should we pick? Greater than 2. 4? 4 works for me. So the derivative is always positive, so the function is always increasing. Let's see if you're right. So here, I have 1 over 3 times the cube root of 4 minus 2, all squared. So here, 4 minus 2 is 2. 2 squared is 4. So this is going to be 1 over 3 times the cube root of 4. So this is also positive. Yeah, that's right. So 2 is neither max nor min. So what the function is going to end up doing is it's going to end up doing something like this. So here's 2. It's going to go like that and back up. So just for a moment, it's going to stop, and then it's going to go back up. So sometimes when we find a critical point, sometimes the value is not going to be a max or a min. What questions do we have about that? Oh, thank you, Math Tutor, for the heart me. I'm sorry I just missed it. But yeah, so with that, let's go ahead and do one more problem. And there are 50 of us in here, so let's see if we can't do a quick mad tap to 6K. So, final problem. And for this final problem, while you're doing a quick math tap, I'm gonna go ahead and give you a definition. So for this problem, we're going to use what's called the extreme value theorem. Thank you, Federal Man, for the follow. So we're going to use extreme value theorem. And what is the extreme value theorem? So the extreme value theorem says that if a function is continuous, where do I live? I live in Maine. I am from Maine. So the extreme value theorem says that if I have a function, f of x, and it's continuous along the interval ab, continuous on the closed interval AB, then the function must have an absolute max and min in the interval. So for example, if I had something like this going on, like let's say I have something like that going on, and I want to pick my interval from here to here. It says that there must be, if this is continuous along an interval, along the closed interval, then there must be an absolute max and an absolute min in that interval. And those will occur either at critical points or the endpoints. So the reason I wanted to show you that was because this last problem we're going to use, and we're going to find the absolute max and min in an interval based on the extreme value theorem. But let's get a mad tap going of those likes. Hopefully everyone's liking this tonight. So let's do a quick mad tap to 6K likes. I know you got it. I know you can do it. I just wanted to show you that because we are going to use that for our final problem. So yeah. Hopefully everyone's weekend is gonna be awesome. I'm just looking for a good problem. Let's see. That one looks good. Ooh, I like that one. Let's do this one. This is a bad example because extrema are a and b, not something within the function. Well, this is within the function, but the extreme value theorem tells us that there will be an absolute max and min within that interval. And that'll either be the endpoints, which in this case there are, or it'll be a critical point. Maybe I misexplained it. But the example I'll give the problem that will serve as the final problem will be a better illustration, I think. All right. Let's see if we can't get the 5K. We're about 200 away. Anyone who's in Calc 1, this made me understand what a derivative was and how, and it all came together. Thank you, Hayden. I'm really happy to hear that. I am really happy to hear that. Let's do a quick mad tap to 5K. We're about 100 away. So I know you all got it. All right, we're almost at 5K. Almost there. Once we hit the 5K, we'll get to the final problem. And then we'll call it a night. Did you graduate with a math degree? Yes, I did. So, I have a bachelor's in mathematics. I didn't actually go for my master's. Just because I didn't want to. There we go. Now we're at 5K. Perfect. So let's go ahead and do the final problem. Where did I go? I went to a small Catholic school in Maine called St. Joseph's. All right, so here we go. Example. Find the absolute max or and min of f of x is equal to x cubed minus 12x minus 1 on the closed interval -3 to 3. Is this calculus? Yes, it is. Thank you, Micaiah, for the follow. All right, so here we're going to ignore this part until after we found our critical points. So now what I'm going to do, first I have to check to make sure that we aren't going to run into division by 0 or any imaginary numbers. So I don't see any division by 0, so we don't have to worry about that. Or I don't see any potential for division by 0, so we don't have to worry about that. I have a calc test next Friday. Please pray for me, y'all. Absolutely, Micaiah. I think you're going to do great. Thank you, Aaron, for the follow. What's the hardest math class you've taken for your degree? For me, the hardest one was differential equations. But that was more because I got really cocky and arrogant. Imperfect says -16. Let's see if you're right. So now now that I've checked, now that I have ensured that my domain is all reals, what I'm going to do, or actually, all that matters is that if any number inside that interval is going to cause one of those problems, which it doesn't. So there we go. So now I want to take the derivative of this function. What is the derivative of x cubed minus 12x minus 1? What would the derivative be? What do you think? J says 3x squared minus 12. P-line says 3x squared minus 12. Imperfect says 3x squared minus 12. Yeah, that's exactly right. Mahoney Ray says 3x squared minus 12. That's right. So it's going to be 3x squared minus 12. So now, again, I don't have to worry about division by 0 in that interval, nor do I have to worry about imaginary numbers. So what I can do is I can now set this equal to 0. 3x squared minus 12. Do you see what I see? Are you talking about the derivative, Micaiah? Okay, so we use something called the power rule. And what does the power rule say? The power rule says that if I have x raised to a power, its derivative, I can take the power, move it out front, and subtract 1 from the exponent. So, I have 3 times 1 is 3. X to 3 minus 1 is 2. And then I can do the same thing here. Remember, a variable without an exponent is the same as x to the first. Negative 12 times 1 is negative 12. X to the 1 minus 1 is 0. So 1 minus 1 is 0. And x to the 0 is 1. And then this negative 1 is a constant. So the derivative of a constant is 0. So that's how I got from here to here. Can you just say it doesn't have an absolute max because the highest power is odd? Oh wait, within an interval. Yeah. So normally, yes, you're right, but I'm only concerned about the piece of this function in this interval. Yeah, you're most certainly welcome, Micaiah. So and then some. Yeah, and perfect. That's right. So I can factor out of 3. I get 0 equals 3 times 3x squared divided by 3 is x squared. And negative 12 divided by 3 is negative 4. So I could keep that 3 there, but instead I'm going to divide it out. That way I can say bye to that 3. Because 3 is never going to equal 0, so why keep it there? So now I have 0 equals x squared minus 4. If that's the case, what would x be? Me says x minus plus minus 2. Imperfect says negative 2. Micaiah says 2. Key lime says positive 2 or negative 2. Yeah. So its critical points are 2 and negative 2. Right. We're looking for the critical points that are within our interval. So if I did difference of squares, this would be x plus 2 times x minus 2. So then, either x plus 2 equals 0, or x minus 2 is 0, or x minus 2 is equal to 0. If x plus 2 is 0, then x equals negative 2. And if x minus 2 is equal to 0, then x equals 2. Both of these numbers appear in my interval, so they are acceptable for critical points. Now, we have 4 candidates for for the absolute max and min. So instead of plugging in these to figure out which ones they are, although we could do that, what I'm instead going to do is I'm going to go ahead and plug in all 4 of those points into the original function. Whichever one gives me the highest number is going to be my absolute max, and whichever one gives me my lowest number will be my absolute min. So we're going to find f of negative 3, f of negative 2, f of 2, and f of 3. So first, let's plug in -3 for x. So the function, remember, is f of x is equal to x cubed minus 12x minus 1. So I'm going to plug in negative. I'm going to start by plugging in -3 everywhere I see an x. So I have -3 all cubed minus 12 times -3 minus 1. Maybe I should have given myself a little more space for these. Yeah, I probably should have, but oh well. -3 all cubed is the same as -3 times -3 times -3. -3 times -3 is 9. 9 times -3 is -27. -12 times -3 gives me plus 36 minus 1. -27 plus 36 is 9. Minus 1 is 8. So far, we have a contender for both absolute max and an absolute min within that interval. Now, let's plug in -2. So I have -2 all cubed minus 12 times -2 minus 1. -2 cubed, all cubed, is going to be -8 minus -12 times -2 is plus 24 minus 1. Yeah, I definitely should have given myself more room for this. -8 plus 24 is 16. 16 minus 1 is 15. So now, that tells us that f of -3 cannot be the absolute max. But it still could be the absolute min. Let's find out. Plug in 2. 2 cubed minus 12 times 2 minus 1. What would f of 2 be? $15, you think? Okay. Almost, Omar. Micaiah says -17. Yeah. Me says -17. Yeah. So 2 cubed is 8 minus 12 times 2, -24 minus 1. 2 cubed 8 minus 24 is -16. Minus 1 is -17. So f of 3 no longer qualifies as as the min, so we can eliminate it, or at least I'll eliminate it. Now, let's see what we have here. So I'm going to plug in 3, so I have 3 cubed minus 12 times 3 minus 1. What would that equal? Me says -10. 3 cubed is 27. 12 times -12 times 3 is -36 minus 1. Micaiah agrees. Yeah. 27 minus 36 is -9. -9 minus 1 is -10. So my absolute min is the smallest number of these four, so that's going to be -17, which occurs at x equals 2. And the absolute max is 15, which occurs at x equals -2. And that's it. And with that, we're going to go ahead and call it a night. Hopefully everyone had a good time learning about critical points. Before I go, I'm going to go ahead and plug some things. So first, as I said before, all of you, if you want to find me here is my channel over there. And this is the set of all actions that you should do when you view that channel. You're most certainly welcome, GoGo. Do I do statistics? I certainly do. And then here, if you want to follow me on TikTok, you can follow me at Robert the AP Math Guy. And then, hey Dimples, how's it going? Welcome on in. So now, thank you GoGo for the follow. So from here, I'd like to recommend a couple of different TikTok accounts that I highly recommend that you follow. The first one is ACG Math Tutoring. She does a really good job covering the ASVAB, the Accuplacer, the GED, the TEAS test. Thank you, Learning with Lynette, for the heart me. She also does a really good job at getting people giving refreshers on algebra and geometry. So she's really awesome with that. And then also, I want to recommend Learning with Lynette. She's actually in the live right now. So she is here. She's the one that just made the most recent comment. She does a really good job with the abacus. And I assume that she just finished up her live. Perfect. Yeah. Called it. So yeah, so she does a really good job with the abacus. I don't think she's going live again tonight. Would that be right, Lynette? Fair enough. So yeah, she does a really good job with the abacus. She makes it really fun. I didn't honestly think I was going to be learning a lot about the abacus when I joined TikTok, but funny how things tend to happen sometimes. Also, I am an online math tutor, so I offer tutoring for groups and one-on-one. So, for group tutoring, I offer it to groups of 3 to 10 students who are all taking the same class at the same time. But you don't have to be taking it with the same teacher or even in the same school. So if you and four of your friends are all taking linear algebra, then you can sign up for group tutoring. And the cost for that is $35 per hour per person for the 2025-26 school year. And then I also offer one-on-one tutoring as well. So if you're interested in either of those, please feel free to DM me and we can schedule a free consultation. Well, not part of your bucket list. Nope. I didn't like that. I didn't even think I was gonna learn about the abacus, but it's really cool. And then I have a new live schedule that I am starting on not next Monday, but the Monday after. So here is my new live schedule. So starting Monday the 6th, I'm going to be doing my first live at 2 p.m. Eastern. And that live, we're going to cover all things from algebra to pre-calculus. And then my second live is going to be moving from 11:30 to 10 o'clock p.m. The main reason I'm doing that is because I'm finding that my sleep schedule is not as good as it should be. So I'm thinking I took a look at the analytics and I saw that by moving this an hour and a half back, not a lot is going to change, but it might help me get to bed sooner. And for that one, I'm going to cover all things calculus and beyond. Well, at least that I know of, because there's a lot of things beyond like linear algebra and differential equations that I don't know. How long are my lives? So I aim for about an hour and a half to 2 hours per live. So, like I said, this starts on October 6th. So for now until then, I'm going to be keeping my single live at 11:30 p.m. Eastern, but after on the 6th, I moved to this new schedule. Also, there are also a couple other things that I am currently working on, and I should have an update for you on Monday about them. So, I'm working on a set of calculus flashcards, which are I'm finding to be so my first set are probably going to be involving simple derivatives, but I'll expand on them as time goes on. I'm also working on a calculus tips and tricks book to because let's face it, you could go online and find every derivative rule under the sun on a single page, but I find that those are great, except sometimes it's like, okay, when do I use this? When do I use this rule? When I use this rule when and this when and this rule and that rule when? Rather than do that, I want to share with you the tips that I give to help you succeed in calculus, as well as I'm also working on a calculus notebook. Um, that's proving to be a bit harder than I thought it was going to be, but I am more than sure that we are going to be. And as soon as all three of these are done, I'll have them available on my TikTok shop. So yeah, with that, I'm gonna go ahead and see if I need to stay on a little bit longer to hit my next goal. When will you be going live again? So my next live will be, well, for me it's today at 11:30 p.m. Eastern because it's 1:30 over here on the East Coast, but it's every day from now until October the 6th at 11:30 p.m. Eastern. But the natural logs will and but the natural log tomorrow we're going to be going over concavity. Oh wait, I might throw in a natural log problem. So let's see. All right, so with that, I hope you all had a great evening, and I will see you all tomorrow at 11:30. Bye, everyone.